So good day. So today I will discuss to you consolidation, which is still part of foundation engineering. And after this one, the last topic is the design of footings. So for the consolidation, uh, we have three broad categories of soil settlement. We have the immediate, primary, and secondary. But before on that, uh, consolidation is synonymously related to compression. Specifically, when the construction of foundation, or other loads is the reason why there is the compression of the soil layer. Of course, uh, we all know that the loads are always carried by one structural member to another structural member, and it will be the foundation that will carry all the loads. Then that loads will be distributed to the soil. So because of the stress increase by the building, it compresses the soil layer, and of course it will compress the soil layer. And we have here the causes why compression takes place. The first one is deformation of soil particles. Of course, soil particles, I mean, uh, yeah, soil particles composes of the solid one. Then you have the water and the voids. So if there is deformation of soil particles, there will be compression. And of course, if there is compression, there will be relocation, meaning some solid parts may transfer from one direction to another direction. The same is true with the voids and the water. And the last causes of compression is there is expulsion of water or air from the voids, meaning it becomes solid soil only because all the extra spaces surrounded by water or air are already removed due to that compression. I mean due to that load. And of course, if that were be removed, the tendency is it will be freely compressed. Okay? So in general, the soil settlement caused by load may be divided into three categories. We have the immediate, we have the primary, and we have the secondary. So for immediate, this is caused by the elastic deformation of dry soil and of moist and saturated soil without any change in the moisture content. Meaning, when we are talking about elastic deformation, there will be a time that it will go back to its original uh, form when the load is removed. Okay, here we are not changing any moisture content. Okay, the same moisture content. Okay, but there is deformation. Then this calculation for the immediate settlement are based on equation derived from the theory of elasticity. Then the second one is the primary consolidation settlement. This is the result of volume change in saturated cohesive soil because of the expulsion of water that occupies the body spaces. So primary consolidation settlement happens when when the when the water that occupies the void spaces are already removed because of the compression action or because of the load that compresses the soil particles, and that settlement is called the primary one. Okay, so I will repeat. For the immediate, this is the cause of elastic formation of dry soil without any change in the moisture content. While primary happens when the water were removed because of the or there were some expulsions of the water because of the volume changes that occupies the void spaces. Then the secondary consolidation settlement is observed in saturated chaos of soil and is the result of the plastic adjustment. Okay? So, meaning, secondary settlement happens when expulsion of water has been done or has been uh, already result of that. So this plastic adjustment will lead to secondary, meaning even the load will be removed, still it will not go back to its original size and shape. Okay, it follows the primary consolidation settlement under a constant effective stress. So meaning secondary happens after the complete primary consolidation settlement. So fundamentals of consolidation. When a saturated soil layer is subjected to stress increase, okay, of course, this stress is increase is caused by the weight of the building, okay. The water pressure suddenly increases. Go back to the formula of the pressure. We knew that the effective stress is the stress total minus the pore water pressure, okay? But of course, as you go deeper, uh, the effective stress increases as the pore water pressure also increases because the pore water pressure is dependent on the height with regards to the data of datum of the water table. Here we assume that the water table is exactly on the ground. That's why if there is increase in the it says here saturated soil Okay, so if there is stress increase, there is also pore water pressure increases. So in sandy soil that are highly permeable, meaning it has the ability to permit the water to move. The drainage caused by the increase in the pore is completed immediately. Pore water drainage is accompanied by reduction of the volume of soil mass resulting in settlement. Because of the rapid drainage of the pore water in sandy soil, immediate settlement and consolidation take place simultaneously. Okay? So here the total stress increase, the pore water of course there will be effective stress increases. Okay? So as I mentioned a while ago, as you go deeper, your total increase of course will be increases, right? Because our reference for that is whatever the pressure created by the density of each layer times the height, while the pore water pressure is dependent on the datum from the water table to the whatever depth it is, okay, in reference to the total stress. So effective is a difference between the two. So here this is a review. Delta sigma or the total stress is equal to the delta sigma prime, which is the effective stress plus the water pressure. Okay. So one-dimensional laboratory consolidation test. So the one-dimensional consolidation testing procedure was first suggested by Tersagi in 1925, and this test is performed in consolidometer. Sometimes it's called oedometer. Okay, this is a schematic diagram of consolidometer, this one. Okay, so what will happen here is you have the porous stone, specimen ring, and the soil specimen. So it is submerged in water and there is a dial gauge. Then it will push until the soil specimen will be compresses or deformed. So the specimen is placed inside a ring with two porous stone, one at top and one at bottom. The specimen are usually 63.5 mm in diameter and 25.4 mm thick. The load on the specimen is applied through a lever arm and compress is measured by micrometer dial gauge. The specimen is kept underwater during the test. Each load is usually kept for 24 hours. After that, the load is usually doubled, thus doubling the pressure on the specimen, and the compression measurement is continued. At the end of the test, the dry weight of the test is determined. So the general shape of the plot, okay, we will see the plot of the deformation. So here, what we can conclude here is it follows three stages. Okay, the first one, initial compression, which is mostly caused by preloading. Okay, so initially compression takes place even there is no load. Okay, it is called initial. Okay, then secondly is when you apply the load, excess pore water pressure is gradually transferred into effective because some of the water occupied on the voids are removed. Okay, that is the primary consolidation, and of course for the secondary occurs after complete dissipation of the excess. So after all the water are removed in the soil particles, okay, when this happens, it's already in the primary consolidation. But when some deformation of this takes place because of the plastic readjustment, okay, because when you remove the water, it will be pure solid particles. But of course, when you remove the load, there will be some readjustment. What will be the how the soil behave? So it is called plastic readjustment, and this will take place or it will fall under secondary consolidation. So here the stage 1 is the initial, wherein there is preloading condition. Here is apply the load and all the water are removed because of the force and because of the compression that happens inside of the soil particles. And in the secondary, when all the waters are removed in the soil particles, it will undergo a certain process called plastic readjustment. Okay, or there will be a specific behavior. What will be the behavior of the soil particles when you remove the what do you call this one? The water. So void ratio pressure plot. So after the time deformation plot for the various loading are obtained in the laboratory, it is necessary to study the change in the void ratio. Okay, meaning initially there is void ratio or initial void ratio, but after you do the experiment, okay, there will be changes in the void ratio. Okay, of course it will vary because void ratio is the ratio of the voids over the solid. Okay, these two are different because the first one is like the usual one, but the second one is when you compress it. Okay, so calculate the height of solid is weight of dry specimen over area of specimen, specific gravity, and the weight of the water. Then calculate the initial height of voids. So this is the total area, initial. Of course, when there is compression, the two will divide it into two, the solid and the void. And of course, there will be delta H1 and delta H2. So, delta H1 over height of solid is called the delta E1. Okay? So delta H1 is obtained from the initial and the final dial gauge of the loading. This is taken based on this one, okay, the dial gauge. So calculate the new void ratio E1 is EO, which is the original minus the change of E1 or the delta E1. You get it? E1 is the new void ratio. EO is the original. Delta E1 is the change in void ratio. Then the void ratio E2 is at the end of the consolidation. Okay? So here E1 is actually the cause of the sigma 1 and E2 is the meaning in the when you consider E1, the void ratio at E1 is at what stage thus there is change of sigma prime 1. Okay? So I will repeat, delta H1 is the you can take this one from the getting the loading from the dial reading of the odometer, which is you can calculate the delta E1. Then E1 is the new void ratio is original minus delta E1. Then E2 happens at the end of the consolidation. So of course, yeah. So this is the graph. So let's go to normally consolidated and over consolidated. Okay. So how can you determine these two, or how can you categorize? Normally consolidated is when the present effective overburden pressure is the maximum pressure to which the soil has been subjected in the past. Meaning considering the effective pressure or the effective overburden pressure, you assume that the present effective overburden pressure is already the maximum pressure the soil has been subjected in the past. Okay, meaning whatever the overburden pressure as you assume as of today will be the maximum pressure that the soil has been subjected in the past. While over-consolidated is the present effective overburden pressure is less than that which the soil has experienced in the past. Okay? Meaning here in the over-consolidated, the one that you assume as of now is lesser. Meaning there have been a overburden pressure more than the present overburden pressure. The maximum effective past pressure is called the pre-consolidation pressure. So here there is a certain ratio. To determine the over-consolidated ratio, you can just get the ratio of the pre-consolidation pressure over the present effective vertical pressure. So This will be your, you just read this one. So consolidation, calculation of settlement from dimensional primary consolidation. Here, just review the derivation, how it was derived. So this is the formula. So the formula for for the primary consolidation settlement is CC times H over 1 plus EO log of sigma prime O plus delta sigma prime over what do you call this one? Sigma prime O. Okay? What are those that value? So, you can use this one. You can use this one also. Okay? So here, H is the height. EO is the initial void ratio. Delta E is the change. Meaning this is E2 minus E1. The final and the initial void ratio. So here, CC is the compression index and CS is the swell index. CS. What is the difference between this one and this one and this one? First, let's compare the two. This is for normally, this is over consolidated. So for over consolidated clay, we just need to compare this one, the total. If the total pressure is more than the effective pressure, use this one. But if it is less than the total pressure, you can actually some books this is sigma total. This is the effective plus the change of sigma, or sometimes it is called the overburden pressure. Okay, if the sum of this is more than the effective stress, use this one. If not, use this one. Again, these two are used for over consolidated. This is for normally consolidated clay. Okay. So, compression index, CC 0.009, LL minus 10. This is for undisturbed and for remolded clay. And of course, this is for region in America. Chicago clay, all clay. So for the time being, that will be the theory only. So I will upload video by today. how to use this formula, and we will have examples on the the problems. Okay, so thank you for listening.